Since oxidation reduction or redox reaction involves the transfer of information and the changes charges in the reactants and product side. So it is very important that we can balance the reaction. So ion electron method is one of we have in the syllabus. So we can balance the reaction. So if we look back here, the many redox reaction in aqueous solution involve water that makes hydrogen ion or hydroxyl ion. So we need special way to balance the. Balancing the equation cannot be done by inspection in that case. So need method to balance equation correctly. Start with acidic solution, then work to basic condition. So we will try to start how we can do in acidic solution, and we will also explain the way how we can do even if we have the reaction in basic condition. First, we have to divide equation into two half reaction. As we know, oxidation and reduction reaction occur simultaneously. So we need to divide it two half reaction, oxidation half reaction or reduction half reaction. So let's see, and then we have to balance the atoms first, other than that hydrogen and oxygen atom. So for balancing oxygen atom, we need to add water to side that needs. And to balance hydrogen, we need to add hydrogen ion to side that needs hydrogen. And then balance neat charge by adding electron. Make electron gain equal electron loss. So first we have to divide the half reaction, then we have to balance the atoms except hydrogen and oxygen, because for balancing hydrogen and oxygen is not not normal. We have to add water to balance oxygen to the side that needs oxygen. Similarly, we have to add hydrogen. We have to balance hydrogen by adding hydrogen to the side that needs hydrogen. And then we have to balance charge by adding electron. Make electron gain equal to electron loss. And then half reactions. We can cancel electrons and anything that is the same on the both reactants and product side. That means left side and right side. Now let's go over with an example and go step by step how we can balance it. So here we can see if we mix the potassium chromate and ferrous sulfate, so KTCr2O7 and FSO4, then the dichromate ion oxidizes ferrous to ferric ion, and Cr2O7 is reduced to Cr3 plus. Now acidity of mixture decreases, hydrogen ion reacts with oxygen to form water. Skeletal equation we have here Cr2O7 ionic equation plus Fe2 plus, that will make Cr3 plus and Fe3 plus. So let's go back to now balancing. First we need to balance in acidic solution. Let's break into half reaction as we said our rule number 1. So Here, the half reaction, first we will write Cr2O7, that will make oxidize to make Cr. Here oxidation will happen. So here Cr3 plus. So let's see. Second half reaction, ferrous to ferric, Fe2 to Fe3. Right. Now our first job to balance atoms other than that oxygen or hydrogen. So let's see. Here we have two Cr2O7 have two chlorine atom. So we have to add 2 close to in front of Cr3O. If we look into the second half reaction, we already have the balance reaction. So we don't need to add any coefficient in front of iron either in the left or right side. Now we have to consider next step to balance oxygen or hydrogen. So to balance oxygen by adding water to the side that needs oxygen. So let's see. So how many oxygen we have? We have 7 oxygen in the left side. So that means in the right side, we need to add 7 molecules of water. First we need to add water and then we need to make sure that how many molecules oxygen, how many atom we have on the need in this side. So we can see the left side we have the 7 oxygen. So that means plus 7 in front of water and 7 water molecule. See, left side has 7 atoms, so we have to add 7. The right side has none, so add 7 water to the right side. Now, here we don't have any oxygen in either side, so we don't need to balance here. Now look into the first half reaction that to balance the oxygen we add water. So now we have hydrogen on that side, correct? So now what we have to do, we have to add hydrogen for balancing the 14 hydrogen in the left side, because we add 7 molecule of water because we had the 7 water atom, oxygen atom on the left side, so we need it. So since we balance the oxygen, and this is our rule that we need to add hydrogen, so now we have to also balance hydrogen. So on the right side we have 14 hydrogen atoms, so we have to add the hydrogen ion on the left side, so make it the same hydrogen. And what was our next rule? Our next rule was, so first I want to again repeat that first we need to write the half reaction for each of the oxidation and reduction. Then we have to balance the atom other than the oxygen or hydrogen. We did it. Then we need to balance the oxygen to the side we need, and by adding water, we did. Then we need to look the every half reaction that we need. So second half reaction, we didn't find any oxygen, so we didn't need to add any oxygen. Next, what we did, left side we didn't have any hydrogen, but right side we have 7 times 2, 14 hydrogen atom. So we had to add the 14 hydrogen ion on the left side according to our rules. Finally, we need to balance the electron. But before that, looks into in the ion side, we don't have anything oxygen or hydrogen, so we don't need to worry about it. Next, when we consider about the electron add, look into first the first half reaction, because Cr2, that Cr2O7, we find this to Cr3 plus. So that means here we have the 3 charges, so, and also 2 chromium. So that means 3 times 2 is 6 net charge. So we have to add 6 electron on the left side. Look into here. So now we have to make sure the net charge on the left side and right side is same. So then how many we have? We have here, see, 14. So we make the same electron both side, and now net charge we have the 14 hydrogen ion and hydrogen C14, and hydrogen charge is +1, and we have also, see, the oxygen. So we have now here 12. This side we have 2 chromium atom and the 3 charges, and the 7, and water is a here is a neutral molecule, so 0. So that means the 6 right side. That's why we need to add 6 electrons must be added to the reactant side, because left side we have 6, and net charge, and left side net charge is 12, and the right side 6. So we have to make it balance. So that's why we add the 6 electron here. And why we had, I just said a few seconds before that, yeah, so we need to do that. Now for the second half reaction, left side was 2 charges and right side 3 charges. So we have to add 1 electron in the right side to make it balance. Now, if we see the both half reaction balanced for mass and charge, I'm again telling that here uh, we need to add water, because we need to balance oxygen if we don't have, and we need to add hydrogen ion if we need to balance water on the side, to the side. Now when we calculate the net charge, we found on the left side the 12. But when we calculate the net charge for the right side, we find the chromium. Because water is neutral molecule, so charge is 0. So 7 times 0 is 7. So that's why we need to add the 6 electron on the left side so that we can balance the both side. Now, let's see the step 4. So now our job, if we look into here, first half reaction we have 6 electron, 14 hydrogen plus, and Cr2O7 here. But in this side, we have 2 chromium 3 plus and 7 molecule water. And if we look into here, the electron ion, here we have the only 1 electron. So that means we have to balance now the electron for the second half reaction also. So that's why, see, we have to multiply the both side by 6 on the second half reaction. And that's why what we got, you can see the first 6 electron plus 14 hydrogen ion and Cr2O7, I mean the first half reaction and the second half reaction. Now, if we do the summation, so what we have here, we have 6 electron, 6 iron, 14 hydrogen, Cr2O7 on the left side, and right side we have 2 chromium, Fe3 plus, 7 molecule of water and 1 electron. Now no one electron, sorry, when we multiply by 6, we have now 6 electron. So according to our rule, we can remove the same ion or same electron on the both sides we appear. Even if we have the water molecule, even not same, but how many water molecule, even if we had, we don't have here, so we could eliminate those. So here, 6 electron. So now what we have, so we have these are our need equation. So 6 Fe2 plus 14 hydrogen, Cr2 2 minus 6 Fe3 2 Cr3 plus and plus 7 molecules of water. So if we look into here, our both side ionic equation is balanced, and this is how we balance the redox reaction in acidic solution. So it initially seems to be lengthy, but it is not so much complicated once you practice. So I want to just repeat that what we saw or what we done for balancing the electron in acidic media. First, we divided the reaction into two half reaction. Let's go back to review one more time. So first step we had break into half reaction and then balance atom other than hydrogen and oxygen. We didn't need to balance the iron, but we need to balance the chromium because left side we have two chromium atom, but right side we have chromium ion, but we need to add two coefficient in front of chromium ion. But iron 1 1, so we don't need to do anything. So balance now oxygen because Cr2O7 have oxygen on the left side. So how many? 7. So we have to add 7 molecule of water on the right side. And when we add water, we have now both sides same oxygen atom. But once we add the same oxygen atom, we find that now we have hydrogen for 14 hydrogen atom on the right side. So that means left side we also have to add the same number of hydrogen ion according to our rules. In case of iron, second half reaction, we don't need to do anything because we don't have oxygen. So we don't need to add water or even we don't need to add hydrogen ion to balance hydrogen ladder. Balance hydrogen by adding, we did it here. Yes, we just did and we don't need it. And finally, we need to find the charge and also make the ion equal, need charge equal. So when we need to do the need charge equal, make the electron loss or gain equal. So that means need charge. So we have to count the electron, correct? So if we look into here, the need charge, we have here 12 and the right side 6 because 3 times 2 6 and the water molecule 0, so ultimately equal to 6. So that means we have to add the left side uh, 6 electron so that we can balance the loss and gain. Now 6 electrons must be added to the reactant side. For the iron, 1 electron we added the product side. So now we have to multiply the second reaction to make it the same electron. So make electron gain equal electron loss, then half reactions. So here the 6 times we need to multiply. Then if you now look into the both side have same electron gain equal electron loss. Cancel the same electron and what we have here, and if we look into the reaction is balanced. So this is how we have to do. Now let's, if we need to do the balance basic solution, so we have to continue these 7 steps and then we have to move move toward the basic solution, how we can balance. The simplest way to balance an equation in basic solution, we have to, as we said, that we have to do on step 1 to 7, and then we have to add hydroxyl ion to both sides of the equation as there are hydrogen ion. So combine hydrogen ion and hydroxyl ion to form water. And cancel, we need to cancel water that we can get from both sides. So let's see. So we will use our same example is here. So 6 iron, 14 hydrogen. We have the 6 iron. This is our equation. So here, we had 14 hydrogen ion. So that's why we have to add 14 hydroxyl ion on the both sides. So then what will happen? The 14 hydrogen ion and hydroxyl ion will make water here. And here we have 7 molecules of water, 14 hydroxyl ion. So we will eliminate 7 molecules of water from both sides. And then this is our equation. So this is our final balancing equation. If you now match the charts, it will be the same on the both sides. Yeah. So now if you look into the left side, we have 7 molecules of water, where 14 hydrogen atom. Yeah, here we have also the same. See, here we have 7 and 2 oxygen. So here we have the same oxygen. Right. You can figure it out which of the following is a correctly balanced equation. There is another example for MnO4 and ACSO3. So balance the following equation in basic solution. So we have to break into half reaction. We have to balance other than of oxygen. So if you see here, Mn atom are how many? There is a Mn ion. So balance for Mn already. Balance for AC same. Now we have to add CMnO4, Mn2 plus, and how many oxygen we had? 4 oxygen atom. That's why 4 molecule of hydrogen. To that side, we don't have water, oxygen. And now the left side, we need to add water because we don't have any hydrogen. 4 times 2, 8 hydrogen. So we have to add also. Oh, but before that, look into here. The second half reaction, right side, we had 4 oxygen, and the left side we had 3 oxygen. So that means we have to add 1 molecule of water to make the same number of oxygen on the both sides. Now add hydrogen ion to balance the hydrogen for both half reactions. So 4 times 2, 8. So 8 hydrogen ion. Now right side, for the second half reaction, we have 3. So 3 hydrogen ion we have to add on the right side, while we don't have any hydrogen, 3 hydrogen. So we have to add those as an ion. Now we have to balance net charge by adding electron. So this side we have 2 Mn plus water molecule is neutral 0, so 2 plus 2. And the left side we had the 8 and hydrogen and 1, and here MnO4 charge negative 1. So our Mn, so Mn is negative 1, and this is 1. So total we will have plus 7. So that means 5 electron we need to add on the left side to balance the net charge. Similarly, for the second half reaction, if we look into the net charge, water molecule neutral 0, and this is minus 1. And the right side we have minus 2 plus 3 hydrogen, so plus 1. So that means we need to add 2 electron on the right side, because you can see the negative. So we have to make it equal on the both sides. So now we have to look into, for the both reaction, the number of electron gain or loss we add, that should be equal. So in the first reaction we have 5 electron, but second half reaction we have 2. So here we go, the how we can do. When we see the odd and even, the easiest idea or trick to just swipe the number. So for the take the second number of electron to multiply the first half reaction, and take the first half reaction number of electron to multiply to the second half reaction. So both sides then will be 10. Let's do that. So 2 times 5 electrons, first half reaction, and 5, if you multiply with 5, then 5 times 2, 10 electrons. So that means it is now number of electron gain and loss is equal. So now let's see what we can eliminate the same things. We can eliminate the same number of electrons. We can eliminate the, see here the 5 water, right side we have the 8, so we can eliminate the 5 water, then we will have the 3 water. Here we have the 15 hydrogen ion, here we have the 16 hydrogen ion, so we can eliminate 15 15. So then what we will have remaining, this ion. So now if we look into here, so the equation is balanced in acid. So now we have the hydrogen ion in the left side. So if we have to do the now method in base, so what we have to do, we have to add the hydroxyl ion to both sides of equation, as there are hydrogen ion. So for the first reaction, we have hydrogen ion. So then we have to add hydroxyl ion for the second half reaction, because we don't have any hydrogen ion there. So when we had the hydroxyl ion on the both sides, what we get? Hydrogen and water combined to water. And this side is remaining the hydroxyl ion. So we have now 1 mole water, 2 Mn ion, and right side we have 2 Mn ion and 2 mole water plus, and then you can see what we have here. We need to now again cancel out, and finally we have. Now if we look into here, if we count the ion atom, both will be same. For example, 2 Mn, 2 Mn. For example, 4 oxygen, 4 plus 3, 7. Here we have 4, 5, and then 2 oxygen, hydrogen, 5 hydrogen, 2 to 4, and 1 is 5. That means the reaction is totally balanced. So this is how we need to do, and we have some, you can practice here. And other we all describe and review on the class. And one thing we need to do here, that's that, not these are, we already done all the things. So what we have to do here, according to our learning goal, one more things we have to do here, redox reaction, titration. Yeah, this activity series, we talk and we will talk more laterally. So now we have stoichiometry in redox reaction. So we can balance our redox reaction and use stoichiometric coefficient to get the relationship mole to mole, and then we can solve some. So what type of problem we can solve? So we start them with mass or volume of one reactant and find the mass of volume of product. For titration, and we can find the reactant calculations and also the percentage yield. So here, let's see what we have. How many grams of Na2SO3 are needed to completely react with 12.4 gram of K2CO2, the mass per gram per mole? So first we need to balance the equation, then we can set the mole to mole ratio. So if we balance our equation, so what we have here, we can see. So this is our balanced equation. So Cr2O7, SO3, and SO4, Cr2 for water. And you can follow the same procedure that way. You need to write the equation and then you need to balance it. Then do the calculations. So we have the gram of Na2SO3. We have to find out. We have a gram of K2Cr2O7. So if we look into the relationship, we will find the Cr2 and SO4 relationship. Let's look into here. So the moles of Cr2O7 and moles of SO4. Because when we react, we find the SO4. So this is our relationship we need. So we have the gram of K2Cr27, but we need to find the gram for Na2SO3 we need. So if we look into now balance reaction, so the balance reaction, see the 1 mole of Cr2O7 and 3 mole of SO4, this iron. So in that case, the moles ratio will be Cr2O7, 1:3. So now what we have to do, we have the gram of, this is the similar that we have already tried in previous chapters. So gram to mole and mole to, we need to find out the moles of this one. And then we need to convert the mole of Cr2O7 ion to mole of SO4 because we know the relationship. So first gram to mole, and this is the similar we have already tried in other chapter. But what is new here, we have to balance the redox reaction first here. So gram of potassium dichromate to mole of potassium dichromate, and we know our ion ratio. So 1 ratio, we have to convert into mole of ion. So that's also the new part, because before we did that directly from, because that time we didn't need to do the ion, but here during the redox reaction we need to convert it ion. So 1 mole chromium ion and 1 mole the ratio. So then we will convert into ion, and then you remember that we have the mole ion ratio between the Cr2O7 and the SO. So yeah. So that's next we are going to use it. See, yeah. So SO3, and because we need the sodium sulfide, so SO3. So do not be confused. SO3 and SO4, sulfide and sulfate. I will say that that's why SO3 and SO4. So now we have mole, and if we have mole, we can easily calculate the mole to gram. So finally, mole to gram. So mole of SO3, and this is also the ratio between 1 the sodium sulfite and 1 mole sulfite ion, and we know the molar gram. So we will find it. This math is little bit of lengthy, but yeah, we can do that actually. This is too lengthy, yeah. This is our answer. So now see the redox titration. So equivalent point reached. Titration, we know that normally we do the acid phase titration, find the end point, so to neutralize the reaction. And here the end point or equivalency point reached when the number of moles of oxidizing and reducing agent have been mixed in the correct stoichiometric ratio. So this is the difference. There is ion. So oxidizing agent and reducing agent, when we will have the same amount. So that means we will have, for example, if we have a titration vessel and if we have a burette here, so we are going to add either oxidizing agent here and reducing agent in the reaction vessel, or vice versa. And we have to have our same amount or ratio, same ratio. So no simple indicator to detect this endpoint. So there are 3 useful oxidizing agents that change the color: potassium permanganate, dichromate, and iodine. So deep purple to fade the colorless for potassium permanganate, potassium dichromate, black K2Cr2O7, bright yellow to orangish, and 3 ion, which reduced iodine in the presence of iodide ion forms I3, which forms dark blue complex with starch. And so these are the useful oxidizing agent we can use which change color in during the equivalency point. Redox titration. What we have to do. So this iodide react with IO3 ion in acidic solution to form I2 solid that is not dissolved in aqueous solution. 3.34 mole ml of 0.5678 mi is needed to titrate. This ml of solution contain this. What is the molarity of the solution? So first what we have to do, we have to write the unbalanced equation. So we can see that this is oxidized to I2 and IO3 is reduced to I2. Now we have to balance the reaction. The reaction occurs in an acidic solution. This is the similar way that we do. First atom, then oxygen by adding water, then hydrogen ion to balance hydrogen, and finally electron loss or gain. So here are our balance equation. So not done as not lowest whole number coefficient. So then what we have to do? We have to find, see, not done as not lowest whole number coefficient. Okay. So here we have to divide the 5. Yeah, so when we see that we can make it more simple whole number, so we can do that. So here we have the 5 times 2 iodide ion, 2 IO3 ion, 12 hydrogen ion, and this side we have I2 and 6 ions. Can make it more lowest whole number by dividing. So we have this one. This is our equation right now. So now we have to calculate millimoles of this iodide titrated. So we have this information. If we look back into here, yeah, this molar iodide is needed for the 25 ml, and this is the amount. So we have this ml, and we can convert because we have the information. We remember that we study the 1 molar. That means we have per ml this amount. So if we now convert, we will find 7.007 mole iodide. Convert to millimole of IO3 present. Similarly, we did it. So the ratio we have from the chemical reaction. Very good. The 5 and 1 ratio. And then we will find this 1.401 millimole IO3. Convert to molar M. So what we can do? So millimole. How many ml? 25 ml IO3. Look back into the question. 25 ml. See? So we can convert into capital M. So this is how we want. Yeah. See? What is the molarity of the solution? So these are the steps we need to do. Let's do the one more example. Yeah, we have some example here. So 0.3 gram sample of tin ore was dissolved in acid solution. The tin to tin 2 in a titration. This ml of this is the concentration of permanganate was required to oxidize into tin 4. What was the percentage tin in original sample? So here we go. We have to do the balance the reaction the same. And what we have the, we know this is our equation. Capital KMO4 times 4 into mole. So now we can just, and this we can now convert to mole of SN and potassium permanganate. But equal to mole of tin. So now we have mole of tin 2 times equal to gram tin in sample. So we can now convert to percent SN equal to gram. SN by gram sample, we know that. So we can times. So let's see the first equation what we have. We have this amount of potassium permanganate times the volume, and we will find the potassium permanganate. Now we need to convert millimole of manganese and there to SN5 because we know the ratio here, and this is oxidized to tin 2 to tin 4. So this is the reason we have to do the convert here. Millimole KMnO4 to millimole MnO4 and millimole SN2 plus. So this is our conversion. So we have the relationship between MnO4 and KMn. We always know that what unit we need to do the convert, we need to write on the top as a conversion factor. Then we have this is 3:2 ratio between the millimole SN2 plus and MnO4 negative. So we will find this is step 2. Now finally we have to find the gram and percentage. So millimole SN to SN and then gram of SN. We know the gram of we can find from the periodic table and we can calculate. Yeah. And then we know that this is just milligram to gram convert because we need to do the percentage into gram. So this is our gram. And finally, we know that this is we have and what we had the total amount existing. See, there we go. We have the, so we find the 0.07, but we had the 0.3 gram or total. We know the mixture. Yeah. So the percent sample we had 24% tin in this O. We'll find out. Yeah, here's some example. So that's all. You guys can practice.